optimization முடிச்சிருவோம், then later we will go on. So this is actually MATLAB software. You can write all your equations directly how you are writing in paper. You can write it, will give the solution. So already I have stored it and will show. This is solution for multi-FDTP, whatever type best solution with the total deviation method. I explain you. This example which I get 500 watts load. So diagram I think explain here. Generator 1 is connected to, that is just through 1 ohm resistor. The generator 2 is connected to the load. This is G2, G1. G1 is connected to load through 4 ohms. This is 4 ohms. So just I have taken in order to prove that a simple example. Because I already told you this is 100 volt constant. I retired details 100 volt constant in order to prove it. And this is the diagram which I translate for this particular concept. Right? If it is valid here, it is valid for any type of algorithm. Right? Any network you can use it. Even a bigger network you can use any algorithm. You can definitely, if you accept this concept, then you can really best use it. Now you see that generator 1. What is the definition means? 0, 0.2, 0.4, 0.5 like that 5 ampere. Because 100 volt means here, 100 volt means 500 watts means maximum current is 5 ampere. 5 into 100 means 500 watts load. This is a 500 watts load. So two generators are sharing the 500 watts load. One is first generation to 4 ohms resistor, second generation to 1 ohms resistor. Am I correct? Now understand the problem. Now what is I2? Since voltage is fixed there and current is also fixed 5 ampere. Total load current is 5 ampere. So I2 is depending upon again I1. That's why I have written like this. This is called definition operator in NAPCAR. You can directly define it. I2 is depending upon. Okay. So this. Just you can write the equation. I think simple network only. Because 4 ohms and you see that, and we are assuming the function also. Cost function for the generator 1, generator 2. Similarly, the emission function also. All quadratic equation. Because normally we are taking quadratic function. Already you know for cost function and the emission. And you can ask a question, sir. Nowadays people are doing discrete data. And but you are still going for the conventional method, because the conventional method they modeled the discrete data, they fit into a curve. Best is the quadratic curve. Normally in all analysis they use the conventional method. But now people are using discrete data and they are applying different data. So what? Anyway they are going to optimize it, right? So they can use any method of optimizing it. But now in order to introduce the concept, I have taken a simple model. It's a quadratic function. In the quadratic function, two functions are considered, band 1, band 2. Similarly, S1, S2, slope, I think it's not great. The function and then emission function, you see that? All depends upon the power generated by the generator P1 and P2. Because all this depends upon I1. Why? We kept current is constant load current. So once you decide I1, I2 is also fixed. Simple network, am I correct? Once I1 is, it's a load flow, that's all. It's a balance, feasible operating point. It is simple network. Once you fix the I1, I2 is also fixed. Constant is, already I said, the voltage become constant, load. Therefore, 500 watts. Now I think customer can see it is very simple, that's why it's like a simple network. So, here this is the cost equation for individual generator. This is the cost equation for the emission for the plant 1 and plant 2, that is two generator emission. So this is also a quadratic function. So total emission will be adding all these two. Similarly, total cost will be adding this two, small FDI1. That is depending upon I1. This is also depending upon I1. Capital FDI. I think two are the total cost and total emission. See here, loss is also considered because we will minimize the loss also. How we can calculate the loss? 4 into I1 square. Here, loss in the second one, 1 ohms. That's why I2 square. Because I2 is depending upon a function of I1, so I have done like this. Total loss is equal to I1 plus. Am I correct? So this you can directly plot it. That is the advantage of this math card. This is called a text engine. You can just put in column and you can write whatever type of text you can write. You see that first is the cost variation, total cost variation. Second is the emission variation. You see the minimum point here. I1 1.667 will be the I1 is I2 2.53 will be the cost function. Green color. Green color is normally first one, first variable. First variable total cost. When it I1 is 2.53, but emission is 1.667. You can also check up this by see, if you put S1 then I1 equal to, it will display the entire value. Whatever it is internally, it will compute everything. So you can also verify at which point you are getting the minimum value, and you see that 20 watts is the total loss minimum. Am I correct? Total loss, network loss. That cost is minimum is already, I think that will be 204061. I think in between. You can see that this between this. So again I try to find out what is the value of current, we will get the minimum value. So when loss is minimum, cost is how much? You see that? Loss minimum, but cost is higher. So I already told you how much difference is there. It is nearly 18.194. Actually when you are going to minimize the loss, cost will be higher by 18%. It is feasible, but you are facing a lot of deviation from the optimum value, 18%. But actually, you can come for the next emission side also. You can verify with the emission side. You can see that 31.705 is the cost is minimum, but how much the loss is 50% it increased. When you are trying to minimize the cost, loss will be higher. Previously what we have seen, loss is less, what is the cost from deviation. Similarly, this is the maximum, but we are going to combine this single optimization into single objective function, for which we are going to use the deviation. Next, can you see that? FE is the emission, right? FE, total emission. So you will get the minimum value of emission. At that time, what is the deviation? You can easily also compute. Right. It comes around 2.53 actually. And in this case, you can put 2.53, you will get a minimum value. Because entire small incremental is not possible. That's why we are trying to find out what will be the value of I1 at which the emission is minimum is 2.53. Minimum cost is this. Minimum cost at I1 is 2.53 is equal to how much? And I think this is also P1, P2. What is the value of P1, P2 at that solution point? Because we know P1, P2 also depends upon I1. Am I correct? Because already we expressed everything in the equation. Therefore, these are all the designed variables in this case P1 and P2. But we have selected I1. All these things are depending upon I1. That's why very easy to compute all these variables, right? Mathematically. Finally, this is actually final. Say given the entire thing. FD is the cost computation. Am I correct? At any value of I1, it will give the total cost. What is minimum cost? This much. So difference. This is deviation of cost. This is actually loss deviation. Total loss is depending upon I1. This is also deviation. Calculation and deviation of emission. So three objective function evaluated as a different variable, design variables. Design variable means P1 and P2, and we are trying to find out the deviation. So total deviation is this much. So all the three we can plot it. Say DC of I1, that is cost deviation, and loss deviation, then emission deviation in a single graph. You can see that first will be the green color, then red color, then violet, then finally I think of yellow color, this yellow color. This will be the best solution. This is the cost, already you know that 2.53, 1.677 is actually the emission. This will be the 1 ampere, this 1 ampere for the loss, this violet color. Total deviation put together, if you are trying to find out, the total deviation is minimum here. So at which the total deviation, the current at which the total deviation is also I have given a calculation, the best one. What is the total deviation? Actually, the best one. How much deviation in each, I think is given. I will put it here. Cost deviation is this much, then emission deviation is much, cost deviation. This is total deviation. Here I can ask a question. We minimize the total deviation. This is the best one. I said, because for this P1 and P2 value, P1 and P2 value of 1.447 is the giving best solution. All the okay? That is the multi-update best solution. But what is the percentage? Suppose you are trying to limit this only 5%. I am not allowing the cost to go for the optimum value, 9% increase. This shows 9% increase from the optimum value. Am I correct? What is the meaning of this? 9% increase from the optimum value. What is the optimum value which you have got? Some value you have got it. Single optimization. From there, it increases by 9%. I am not allowing it. I am only restricted to 5%. Then it ends up with a single solution. You fix it 8%. Find out P1, P2. That's all. Whatever may be this case, you don't bother about it. But again, violate this one. Again, you have to feasible solution is possible or not depends upon this type of approach. This gives a good conclusion whether you are in a proper track. So we combine the total deviation in a single objective function. We are trying to optimize, we will find the best one. From there, if you deviate any value, definitely other value will be increased. Other deviation will be increased from the optimum value, other objective function. Am I correct? Therefore, you try to find out the best solution, just verifying the first best solution is okay, satisfied means you can take this, is the best solution. Allowed, this is also allowed, this is also allowed, well and good, you get the best solution. No sir, I want only 5% only, then you will end up with only one solution. That solution gives some value of DE and DL. That you cannot change it, because once you fix up the P1 and P2, DC is fixed there. Say, because of DC you are restricted to 5%. For the 5% P1 and P2 you get some value. But that will not give 0.618 rise. Instead it will be higher than the optimum value, deviation, the emission. Similarly, loss is also more than that. For the solution of 5% of DC. Understand? P1, P2 you obtain by 5%, you will raise the Deviation of emission from the optimum value, deviation of last term deviation. But if it is acceptable, okay, that's the best solution. Okay, now follow it. Because all depends upon this design variable P1 and P2 on the solution. Therefore, once you fix up the constraint for the thing, end up the solution. So this concept is very important. Whatever may be the optimization procedure you are following to optimize the function 1, function 2, function 3 individually. And finally, if you form this mathematical objective function using this concept percentage deviation, where the total deviation is minimized, definitely you will get a best solution. That's why I have taken a simple network and I any doubt about this?
What is the significance of the slope you have encountered, sir?
You are correct. See, whenever we are not considering the losses, well and good, we will get the minimum as per the current approach. Current presented equation when you are differentiating the objective function with respect to independent variable, you get the minimum value. Am I correct? But in the case of generation, this power P1 and P2, P1 and P2, you are having F1 and F2, right? F1 and F2 total put together, you are trying to plot it without considering losses. You will get minimum, but that will not be minimum because loss is also there. That's why in, I think you studied incremental loss. So if you neglect it, definitely it will give dfn by dpn is equal to lambda, that you already studied. So that is possible when you are neglecting it, but when you are including the loss, slope equal cannot give the minimum.
How the slope factor is incorporated in the problem formulations?
That is only we can differentiate this. I think I am shown here. Yes. Right. Finally, I will show the how you are going to use this software. And I have given file to refer it, but our that will be very useful. This file is available in your CD. All these files. But of course, you need not use this file. This is actually in order to set up the DOS box. Already I told you, you are using Windows 7 or other OS means you can use DOS box installer. Using DOS box installer, you can install it. Once you install it, you can operate like this. Directly you can run this. Now the executable file is here. This is the executable file. It's a general file. Programs written GW basic. So first it is all network or circuit. See what you have to say, whether it is a network. Network means it consisting of sources and that as well as the loads only. Power system means you have to get generator. And I taken this circuit. First I will take that circuit which I have. Asking whether the file you can fit it in a file or you can keyboard. Keyboard also you can use it. How you can create data also given. That is number of source buses, number of load buses, number of lines. First, then all the lines there. Starting bus, ending bus, starting node, ending node. Then value of the line value in the case of power system. In the case of network, it is a element information, resistor and a reactor. Right? It is AC circuit. It is a DC circuit only. Resistance is there. Other part 0. Susceptance in the case of power system, it will have susceptance. Am I correct? In the case of network, it is 0. So I have already given all the instructions how to create the data file. So I have created already the data file. It is asking data file. Data file is DC4. I think it is actually DC4.8. Whatever proper key, what we say. The file, first we have to say file, then only we have to file. Now it is asking data. Now you have to DC4. You can create any output file. So any file name you can tell me and I can use this. Any file name. 2 characters. Sir, any character. B.
2 characters.
2 characters.
W.
W. W dot out. It is the output file for the. So it displays. Already I show you that network, 2 sources, 2 loads. Node 1 and node 2 is the sources, 3 and 4 is the load. So you can get the sharing of first source with the load at the 3, contribution of source to 4. Any doubt? So already this will be written in the file. Whatever file you mentioned, it will be already written whenever it is displayed. This program is for now it will work for 5 buses totally. Number of source bus, number of load bus, totally 5 bus. That's why it's going to trial. But it's only executable file. Source file I am having. So if you want to increase it, then you have to source program. I have to change it, and again I compile it and do exe. You can use it for any number of buses. Understand? So now you can say that contribute the contribution of each source, the total load. Here is each source to the each load. Now contribution of each source to total load. Total load means all the load and the network can be ordered. You can see that. Yes, you said this case. So the first source contributes 97 watts. The second source is 486. Right? Then the last check whatever result here we have a full checkup, so you can say yes. Active power, because this is only DC circuit, that's why you are 0. If it's a power system, it will give. I will also show the next power system. These are the results which I have already shown before in the PowerPoint. First example. 384 load at 4. So you see that source 1 to 4, source 2 to 4, add load at the point 4. Similarly, load source 1 to load 3, source 2 to load 3, add. So how the two sources sharing the load at 3 and load at 4, and total load how it shares, the entire system how it shares. So for which how to find out 69 and this you have add and you get total load of the entire system is shared by the first one. So first generator total share identified load share. From the injected total power you can minus it, you will get the network loss. Contribution of the source 1 to the network loss. Similarly, contribution of network source 2 to the network loss. You can calculate. How? You can add this contribution of the load source 2 to the entire 1000, that is 122.72, 314.19. You can add together, you find the contribution of 2 to the total system load. Right? Then add it, you will get the total loss of the network. Loss contributed by the first source, loss contributed by the second source, you can add it, you will get the total loss network. And show that balance. You see 1 to 3 and 2 to 3. Contribution of the source, active power, and see how much? 150 watts. And again the info again 42 watts. We can have a check. Definitely you will. This is I squared R loss. The network I have shown, you can calculate the circuit 4 ohms and 1 ohms. So you can calculate the losses at this operating point. You will get losses 42. Similarly, you subtract it, you will get the 42. You can check up the given here. So this is for small DC network. I am coming for the actual power system. Then again I wrote down the program. So now again it is not a circuit, so I said no. Then I am going to feed the data group 5, so I said F. Data variant is asking. So one 4 bus, sorry, I think 4 bus, I think 4 bus 5 line data is given. So the diagram is available in your CD also. So for this, I am going to input this data file is available. All are asking for it, so output file name. So finally I will show the file name also. You mentioned that I will show the file name. Then output file name, you can give another name. W Z before Z. You can add another character. W Z K. W Z K. A circuit also given. Okay, so again you can say same thing, all available in the file which you mentioned now. Similarly, you can split up, everything is given in the. I think you can use this software for finding, sharing of all the active power, everything is given. Similarly, the susceptance is there, susceptance contribution also can be calculated. Because in each line we are having half line charging susceptances. The effect also it will give. For the network it will not give. Ordinary circuit is not used because you are not doing susceptance. But in this case, the data you are going to give the susceptance also by process control. So it will give the say yes, you will get the each bus how much it inject power and what is the significance of and finally it will calculate the loss, calculating actual voltages available across each line, adding up. And finally it is verifying it whether we are getting the same balance or not. Because using contribution theorem only we have separated individual source, how it contributes to the load and as well as network loss. Then finally we are going to add the entire loss contributed by sources, it will give the total network loss. Whether it is correct or not, how to find out? You take the voltage of each line at the particular operating point which you evaluated. You calculate the losses, add it. So this loss and whatever you arrive should be equal. Then your division theorem is true for network for any quantity it is. I think I will show the slide. It is available in the first you said W is there, right? W E. WE dot out. Okay. Because all the ASCII files only, so you can use normal. You will get it. Whatever you got it online, that will be written in this file. So for in-bus system, you can use the package. Total in-bus system, 5 buses maximum. You can select how many loads or how many. Any circuit containing number of sources and number of loads put together not exceeding 5. Network maybe you can use it. And if you want to write to me, then mail ID is there. If you are specifically doing research in this area, if you want to proceed with this package is very simple, anybody can use it. You need not for any bus system. I think any doubts you please ask me questions. And this is a novel information which I have read. Another important information I have to point out. On our this particular theorem actually, how the sources are sharing, how we have arrived. I already told you what is the back power. Physically the power is not from the source to the source, but inherently There is a back power. That's why we are establishing the balance. Am I correct? That's this concept is using the solar. See, we are getting solar power. We are having our normal supply power. Both normal supply power you can rectify, and solar power is also DC.